Hi, this is Dr. Emenacker. In this particular video, we're going to be looking at optimizing inventory costs, actually inventory and ordering costs. When a business orders in a product, okay, they don't necessarily always put every single package out on the shelf. They sometimes will keep things in a back storeroom. This is particularly true of electronic devices. And oftentimes they need to keep these electronic devices in a locked, fenced in area that's monitored with video camera and things of this nature. So what winds up being the case is that when the product is brought in, some of it is put out on the shelves and the rest of it is put back in storage in a monitored situation. This monitoring and locking it up and all this costs money. Okay, let's take a look at what's going on here. We're told that Big Top Electronics sells an average of 3,500 iPads a year. Okay. And the storage cost to secure one iPad for a year is $16. So if you were to just order 3,500 of them in January, some of those iPads wouldn't be sold till December and they would have sat there all year and it'll cost you $16 for an entire year for each iPad that's sitting there. So the security aspect can mount up to some money. Every time an order is placed, there's a $35 ordering fee and a fee of $7 per iPad is charged for shipping and insurance. How many orders need to be placed each year and how many iPads ordered at a time to minimize the storage and ordering costs all put together. In other words, we're trying to minimize the total cost to the business. Well, first off, notice the cost is made up of two elements. The cost is made up of storage of the devices as well as ordering to get them into the store. A first thing to figure out is what is it that we're allowed to vary in this problem? Well, what we're allowed to vary is the number of iPads that we order at a time. And in varying the number of iPads, it will then change the number of orders a year. If, for example, we order 100 iPads at a time, we would take the 3,500, divide it by 100, and that would tell us that we're going to have 35 orders per year. If, on the other hand, we were to place orders with 350 iPads at a time, we would take the 3,500, divide it by 350, and this would give us just 10 orders per year. By decreasing the number of orders per year, it decreases the ordering fee. However, by decreasing the number of orders per year, that means we're taking in more units per order, which is going to increase the security fee. So as the one cost goes down, the other goes up. And what we're trying to do is we're trying to find something in the middle where we save as much as possible. Now, for this particular problem, we're making an assumption, okay? We're assuming steady sales throughout the year and not just a Christmas surge or something of that nature. This is not true of all products. iPads, I suspect, would be one where there are more sold around the Christmas season. Okay, but for the purposes of just setting up and learning how to handle these on a basic level, we're going to assume that this company sells them on a steady basis. So as many of them sell in January, as sell in February, as sell in March, right on throughout the year. We need to figure out two costs. The first cost we need to figure out is the storage cost. The storage cost is going to be the annual cost to store an item. Well, if you'll notice up here, it's $16 per item times the average number that are in stock at any point in time. What really is going to happen is when the shipment comes in, we're going to have a lot of them, and then they decrease in number till we get a next shipment, decrease in number, get a next shipment. So what's going to wind up happening is at some points in time, we're going to have more than the average number. At other points in time, we're going to have less than the average number. But To get an estimate of about what the storage costs are going to be, we're going to look at the average number in stock at any one point in time. The average number in stock is going to be half of whatever it is we order at a time. So if we order 100, half of the time there's going to be more than 100 units back there. The other half of the time there's going to be less than, um, well, the average would be 50, I guess. So half of the time there's going to be more than 50 units back there, and the other half there's going to be less than 50 back there. So the resulting storage cost is going to be the average of too much and too little. Kind of sounds like something from Goldilocks and the Three Bears. Okay. So what's going to wind up happening is we have our annual cost per item. Our storage fee is $16. The average number in stock at any one point in time is how many did we order, and we're going to take half of that as an average number in stock. Multiplying the 16 times x over 2 gives us 8x. The other part of our cost, as you can see back up toward the top again, is the ordering. Now, there are a couple of costs incurred with ordering. One is every time you place an order, they charge you $35 just for picking up the phone or looking online or however they take the order. So you get dinged $35 every time you put in an order. So this means we want to try and minimize the number of orders. However, if we order a whole bunch, as we talked about before, it increases the security fees. So there's a balance here. Okay, so we've got a $35 order per fee, and you're charged $7 per iPad for shipping it and for the insurance on shipping it. So we have a couple of costs incurred here. Let's take a look at what happens for the ordering. We have the cost per order, and we have the number of orders per year. The cost for each order is going to be the $35 that they just flat out charge you for saying, hi, we want to place an order. The other part of the cost per order is the shipping and insurance for each unit that you order. So the cost per order is made up of two components, the ordering fee and the price per unit for shipping. Now, the number of orders per year, well, this varies with the number of units that you order at a time. If we ordered 350 of them at a time, you would only need to place 10 orders a year. We would take the 3,500, divide it by 350 at a time, and that would give us 10 orders. But notice here, we don't know how many we're ordering at a time, so we're going to take the total number of units we need and divide it by whatever that is going to work out to be. So this gives us now an ordering cost of 35 plus 7x. That sum times 3,500 over x. We're going to need to take and distribute this times each of these. The 3,500 over x times 35 gives us this first term right here. Notice it's over the x, so that makes sense. The second term is going to be 7 times the 3,500 over x. So we're going to take the 7 times the 3,500, which will give us 24,500. And notice there isn't any x here because the x in the numerator cancels with the x in the denominator, thereby giving us a total cost for the ordering part of the business. Okay, the total cost for storage and ordering is our storage cost, which is this 8x, plus the ordering cost. Now, notice on the ordering cost here, I've rewritten this term as 122,500 times x to the negative 1. The reason I did that was it's a lot easier to take the derivative. It's always the case that once you get your equation, whatever the problem might be, the next thing you do is you compute the derivative, which we have right here. And then, of course, once you take the derivative, you're going to set it equal to 0. And remember, setting it equal to 0 is not done because it's easier to solve. It's not done because we always set things equal to 0. It is set equal to 0 because the derivative is a slope, and maxes and mins occur where the slope has a value of 0. Okay, so that's why we're setting that equal to 0. Solving for x, and I'll just not bother going through those steps. Solving for x, we wind up with x is equal to 123.744 iPads per order. You know, selling that 0.744 of an iPad is going to be a little tough. Part of it's missing, and most people aren't real thrilled about buying part of the whole thing. What this means is we're going to need to look at ordering either 123 or 124 iPads at a time. If we choose to order 123 iPads at a time, right here, this means we're going to need to place 28.455 orders. If we go with 124 iPads at a time, that would mean we're going to order 20 or have 28.226 orders, slightly less orders. But realistically, you can't place 0.226 of an order. They charge you the whole $35 whether you order 1 or 10 million. Okay, so we're going to need to deal with that. However, before we deal with that, as always, we want to first verify that our solution is a minimum or a maximum. I'm looking at my first derivative over here to the right-hand side, and I'm thinking the easier way to do this is probably just compute the second derivative, which will give us a positive 24,500 x to the negative 3, which gives us 24,500 over x cubed. Now, whether I use 123 per order or 124 per order, the denominator is going to be positive. So we're going to have a positive numerator divided by a positive denominator. I don't know what the number is. All I care about is positive divided by positive gives me a positive number. If the second derivative is greater than 0, it tells you you have a minimum. Whether we choose to go with 123 or 124 is still to be decided, but we know that our solution is a minimum, it's not a maximum. Okay, so how do we go about determining whether we want to use 123 or 124 units per order? Well, we go back to our original total cost function, and if we substitute the 123 into the original function, we get a cost for the year of $26,480. Now, this $26,480 is the cost to store the units, as well as the cost to get them shipped to the store. Notice in either case, in this situation, it's not always the case that the two costs wind up being the same. But in this situation, the two costs are exactly the same, which means, you know, you can go with either route. It's going to work out to be the same cost in the end. If we choose to do 123 at a time, let's go back up here and notice that if we do 23 at a time, we're going to do 28 complete orders. If we do 24 at a time, we're going to do 28 complete orders. So in either case, a 29th order is going to need to be placed, and the question is, on that last order, how many extra do we put in? Okay, so what's going to wind up being the case here is if we order 123 units at a time, it's going to give us 123 times 28 orders. So over the first 28 orders, you're going to get in 3,444 iPads. The 29th order to bring us up to 3,500 per year is going to be the number we're after, our target number, the 3,500, minus the 3,444, which we receive in the first 28 orders, means the last order is going to need to be 56 iPads. If we choose to go the other route and order 124 at a time, this means we're going to have 28 orders with 124 per order. By the end of the 28th order, we will have stocked a total of 3,472 iPads, which is short of the 3,500 that we want for the year. So if we take the 3,500 minus the 3,472, This means we need to place a 29th order, and that 29th order needs to have 28 iPads in that order. You may need to go through this a time or two or pause this through sections because this is a pretty quick presentation on this. I was trying to keep the video somewhat short, but the good news is you can replay sections that you want to review, and you can also pause the video wherever you might need to. Take care, and I hope things are going well for you.